Next slide. Here I give you some example. Other example are the sequence below is stable or not. If you remember, for stability of the S-plan, here's a S-plan here is a j omega axis, here is a real axis. If you remember, any pole come to the right of my plan, system become unstable. In the left of your system become stable, and you have a different method exists to find about stability and system. Now for the z domain or discrete time, you must careful you don't have any pole outside of the circle. The radius is 1. Then here is a 1, here minus 1. Any pole inside of the circle your system is stable, outside of this become unstable. This is for the discrete time. Here for the S plan, here for the Z plan. Z plan, that means you have some one circle, the center in the origin and the radius around the 1. If any pole inside here system is stable, outside become unstable. This one we will discuss later, just only keep in this mind. For the finding the stability of this system, that the UK is minus 2.5, UK minus 1 minus UK minus 2, and instead of which one is stable or not, we will see together now. Here you take the Z transform of the system, you can find the Z1 and the Z2, and here you find the Z transform. I will tell you how you take the Z transform, is easy, and you can find the Z1 and the Z2. First of all, I will check the first system. If you check the first system, the Z1 and Z2, the pole my system should be inside of my circle. One of them is minus 0.5 is here, one of them is minus 2 is outside of this system, that means unstable. One of them is minus 1 is here, is okay, one of them minus 0.0 is okay, that means this system is stable. Both system minus 0.5 and the 0.7, both of them inside the circle system is stable. Both is inside of the circle 0.5, 0.7, 0.5, 0.7, both sides inside the circle, that means your system is stable. Only you should learn how you can take the Z transform. I can tell you, okay, if u k minus 1, Z transform of the system will be Z minus 1. U k minus 2 will be Z minus 2. This one we discuss later. I will tell you how you can find, just only keep in this mind. That means here will be minus 2.5 Z minus 1 minus Z minus 2 equal to Z. Or I can multiply both sides in the Z minus 2. This one become here Z, here become 1, here become minus 2.5 Z, and here become Z2. If I both side of the here multiply by the Z power 2 minus 2, sorry, what will happen? Will be exactly the same value of the here. This one we will discuss later, just keep in this mind, and we will see together in the future. I think I made a mistake. UAK for me will be 1, not Z. Here just I made a mistake. I will correct myself. If I multiply this one become Z2 here, here is equal to minus 2.5 z and minus 1. If you rearrange it, you'll find the same equation of the here. The same thing for the here and the rest. Okay, this is what they saw. The one of them become out of the circles minus 2 become unstable. Here will be both sides will become stable, and the rest become stable because inside of the circle. And this is the drawing of my system. If you put the different k, you will find the difference of the uak. And if you remember, this system become unstable, you see the system will become the growing up, and this system becomes stable, and this system will become stable, and this system become stable. And easily you can find the unstable and stable system based on the z domain.